Yeah, they look at differences in means between two different groups. And it's not necessarily two different variables, it's one variable, but it's a categorical variable that only has two groups. And we're doing paired samples t-test, which is a little bit different from what we did last write-up. And we did last write-up independent t-tests. Why is it different this time around? Do you guys remember? What's the difference between independent t-tests and paired samples?
Isn't this also within subjects and not between?
Yes, yeah, it's within subjects and not between subjects. So last time we were looking at male versus female. So you could only be male or you could only be female. But this time around, we're looking at the two different types of words and the recognition rate. And you guys both saw critical lures and unstudied items. Each one of you saw both of these types of words. So you guys are going to be comparing yourself against yourself here. So that's within subjects. And our DV is going to be recognition rate. Does that make sense? So our IV is item type, just one IV, and then we have two groups under it, which are the critical lure and the unstudied items. So we're only doing one paired samples t-test this time around. And so how we're going to be doing that is, first, it's a little bit different than the independent samples t-test for analysis. We're going to have to find the means and standard deviations a little bit differently. We're going to have to do it with the analyze distributions thing that we do with our demographics. So if this looks a little familiar, this is how we get like our race and gender and age stuff. That's exactly what you're going to be doing for the studied words, or the unstudied words in the critical lures, to get the mean here, the standard deviation here, and how many participants were in that group. And then to get the t-test itself, you're going to have to go to a different category for analysis. I'll show you that in just a minute. And then this will be the t-test that you'll be recording here. This is going to be your p-value. Remember, it's the probability of less than t, not the greater than ones. And then you're also going to have your degrees of freedom right here. And so this is going to show you your overall omnibus effect, and this is what you'll be reporting in your table. Or in your report. This is a good example of what you could say. Participants' scores on the first exam and the final exam were significantly different. There's where your p-value is. Your t-value, those are mixed up. Oh wow, that is off. Just scoot that over just a little bit. That would be right. And then the p and t values are italicized. I swear that was right on my computer earlier. Don't know what happened. Yeah, and that's supposed to be circled, the p and t values. Okay, so how do we report the means and standard deviations? We're going to go back to the summary statistics here. Once again, that's with the distributions, with the demographic information. So it's going to be the same thing you guys did in your last study. It's the m equals, comma, s equals, with the same basic format. All right, now on to the new thing, ANOVAs. So, ANOVAs are an analysis of variance. That's what they stand for. And this is pretty similar to a t-test. It also requires a categorical IV, and it requires a continuous DV. But what's cool about ANOVAs is it can do more than t-tests. If you only have one categorical IV, and it only has two different groups within it, it's basically the same exact thing as a t-test. You can do either a t-test or an ANOVA. The only difference is the ANOVA is going to give you an F value, and the t-test is gonna give you a t-value, but you should get the same basic results. What ANOVAs can do that t-test can't is it can analyze categorical variables that have more than two groups. So if you have three groups within a variable, so if we wanted to do gender where we included that other categorical variable, so we had male, female, and other in that, or if we were doing race where we had white, African American, Asian, Pacific Islander, other, etc. So this, what the ANOVA basically does is it assesses where groups significantly vary from each other, and it primarily does this by looking at the means and how they vary from each other. And there's different types of one-way ANOVAs. What we're going to be doing for this write-up is a one-way ANOVA with just one IV. So we'll have one IV with multiple levels within it, and then there's also two-way ANOVAs with two IVs, and this is where it gets a little tricky because then you can get into factorial ANOVAs where you can have two or more IVs, and these include main effects and interactions. Have you guys ever heard the terms main effects and interactions? You familiar with them? What's a main effect? Well, I don't know. Alright, well, I'm gonna go over it, so that's cool. So main effects are what we're just gonna be focusing on for this study, so no worries. These are the simple, easy ones. Okay, so main effects is the effect of an IV on the DV regardless of the IVs. And so what's nice is in one-way ANOVAs, that's all you're doing because there's no other IVs. It's just the one IV, so it's only the main effect. But when you get to more than one IV, then you get into interactions. So I'm just dipping your toes into this right now because we're going to be doing this in the next study. Just kind of introducing the idea. So what interactions do is this is when the effect of one IV depends on the effect of the other. So they interact with each other. So your gender interacts with how well you do in a certain subject in school. That's not the best example. I don't like that example, but you get what I mean. Do you? So this is a good illustration of some interactions here. So a main effect would be just if one group was, say you just have one IV here and a DV here, and you're just looking at, okay, is this group here, group 1, different from group 2? That's it. Cool. Okay. So then it gets a little tricky because you're entering this additional variable. So what you do here is you have this IV and this IV. So if you want to look at the main effect of violence, you ignore training. So you'd have to just average these 2 points right here. So the average would be like right here. And then average these 2 points right here for violence. And so that would be right here too. So this average would be about the same. So there wouldn't be a main effect. But you can see that with the training and with not any training, there is a very big difference in how the slope changes. So there's an interaction between those two variables. Does that make sense? And there's also a training main effect, because if you average this point here and this point here, it averages to like here. And if you average this point here and this point here, it averages to like right here. and those would be different. So here, and here. Does that make sense? Yeah, no, think so? And so this is one that would have like no main effects at all, because if you average this point and this point, it'd be right here. If you average this point and this point, it'd be right here too. And if you average this point and this point, it'd be somewhere in the middle here. This point and this point, it'd be somewhere in the middle here. But with no violence and no training, it goes completely up. And with violence and training, it goes completely down. So there is an interaction. All right, so that's just a dip your toes into what the heck an interaction is. Let's get back to our one-way ANOVAs. So this is going to be your output for what you're going to get with a one-way ANOVA for this study. Just ignore the fly. And so what we're going to be interested in here is this omnibus effect right here. This is going to tell you what your F ratio is. That is the main statistic. So like the t-value for the t-test for an ANOVA is an F ratio. So the higher the F ratio is, the more likely your p-value is going to be smaller and therefore significant. Make sense? So this is where your F ratio is right here, and this is where your p-value is right here. And then, this one's nice because this also gives you your means and standard deviations immediately below it, and how many people are in each group. So how you, okay, so this one's not messed up, awesome. So how you report this is pretty similar to t-test, except you have an additional degrees of freedom right here. It's also italicized. The degrees of freedom are found right here. You'll have your conditions degrees of freedom. It's always the smaller one first, and then your error degrees of freedom is the second one to go. And similar to the t-test, the F value is rounded to the hundredths place, and the p-value is rounded to the thousandth. All right. So if the overall value is not significant, then just report the groupings and standard deviations and say they're all about the same. There wasn't anything different. But if the overall omnibus effect was significant, if this p-value is less than 0.50 or 0.05, then you have to do a post hoc comparison, because now we're dealing with more than two groups. So the overall omnibus effect tells you, yes, there is a difference, but it doesn't tell you which groups are different. So that's kind of the nice thing about t-test is like, yep, there's a difference. This, like, the two groups are different. Woohoo! And you can very much easily tell that, okay, there's two groups, they're different. Here we have three groups, and now we have to find out which of the three groups are different from each other. Does that make sense? Any questions about that? Okay. So, what we're going to do for our post hoc comparison is called a Tukey's test. And so what this does is just looks, it does a thorough sweep of, it compares audio, word plus words, that condition, versus audio plus pictures, and then it just does audio only plus audio plus pictures, and then audio plus words plus audio plus pictures, audio only. So those are our three conditions, and it compares each one to each other. So this is going to be your output. Just ignore that. That's not what you. That's not of interest for you. This is going to tell you whether they are all categorized the same. So in this instance, they are all the same. So the A here means that they are in the same group. If any of these were, so say if audio plus pictures had a B next to it, then that would mean that the audio plus pictures would be considered in a different group from the other two conditions. So it would be different from them. And then this will tell you where your p-values are, is right here. If whether audio plus words and audio plus pictures is different, it will tell you there. And this is how different their means are. And then this will also tell you audio only versus audio plus pictures, if that's different. Audio plus words versus audio only, if that's different. Does that make sense? Getting a lot of dead faces or avoiding eye contact. Yeah? No? Alright, cool. Well, so how do we